10.6 Trig word problems level 2. A boat is heading towards a lighthouse. So again, I already stopped and I think lighthouse is something that's vertical. A boat is coming in towards it. So know that the boat is really right here, coming closer to shore. Here's my 90. Whose beacon light, so that just means the light up on top of the tower, is 150 feet above the water. So that's my vertical. Water, light. From point A, the boat's crew measures the angle of elevation to the beacon to be 12 degrees. That should say before they draw closer. So we're going to call this point A and then make a triangle. And that's going to be 12 degrees. They measure the angle of elevation a second time from point B. So remember, they're coming in towards the shore or towards the lighthouse. So I'm going to put point B closer and now make another triangle. And that angle of elevation or looking up is going to be 21 degrees. So 12, 21. Find the distance from point A to point B. Round your answer to the nearest foot if necessary. So I've got to work in a triangle that's a right triangle. So that would be this one. Right now, this one is not a right angle anymore. So I'm going to start here in this triangle and say, okay, and I'm going to call this X. I'm going to find this distance. So I've got from this angle opposite and adjacent, that would be tangent, TOA. Tangent of 21 equals 150 over X. I'm just going to swap and say X is found by taking 150 divided by tan of 21. So X is going to be 390 point, I'll just say 76. Okay, now I'm going to do the whole triangle. So ignore the line I made in here at point B. Here I have the angle and I have this opposite, and I'm going to call this Y. So I'll say tangent again, but this time of 12 degrees is going to be opposite over adjacent. I'm going to swap them. Let's say Y is found by taking 150 divided by tangent of 12. And so that's 705.69-ish. And then I'm going to subtract these two because I want to find just A to B. So if I've got the whole thing and I've got part of it, then I subtract. And I like to keep all the numbers on the calculator, and I'll just hit minus. So it's taking this minus, arrow up here, select this one, hit enter, and it'll give me, nearest foot would be 315 feet. Right, number 2, a boat is heading towards a lighthouse. So again, we got lighthouse. I'm going to try to make it bigger this time. Boat. It's coming in. Charlotte watching a vertical distance of 137 feet above water. Charlotte measures an angle of depression to the boat at point A to be 11. So remember, angle of depression is a horizontal looking out with something down here. So that would be 11 degrees there, which puts it also 11 degrees inside the triangle. At some later time, Charlotte takes another measurement and finds the angle of depression to the boat now at point B to be 47 degrees. So that would be 47 here, which puts 47 inside of here. Find the distance from point A to B. So now the process is the same. Doesn't matter which one you start with, but you're going to have to do a tangent of 47 is 137 over something, and tangent of 11 is 137 over something, and then subtract those two to find the difference. So I called this X, and I did tangent of 47 is 137 over X. Swapped them so I could take 137 divided by tangent of 47, got 127.75. So now my other one would be my tangent of the 11 is going to be my 137 over, I'll call it Y. So Y will be found by taking 137 divided by tangent of 11. And that's about 704.8. And then subtract them. 577 feet. Okay, and then the last one. Michaela spots an airplane on radar that's currently approaching in a straight line, and that will fly directly overhead. The plane maintains a constant altitude. An altitude is just a height, so that's your vertical. So I'm going to put height here of 5750. Michaela initially measures an angle of elevation of 16 to the plane of point A. Sometime later she measures an angle of elevation of 31 to the plane of point B. Find the distance the plane traveled from point A to B. Round your answer to the nearest foot if necessary. So it's approaching her in a straight line. So let's put Michaela back here. Here's our 90. So she's looking up to a plane that is at point A. And that is an angle of elevation of 16 degrees. Then she measures an angle of elevation of 31. So now the plane is getting closer to her at point B. We're going to make another triangle here. And then this whole angle is 31 degrees. So you've got this triangle, and then you've got this triangle. Find from A to B. So again, we're going to have to work in one whole thing, one whole triangle using the 16. That would be opposite over adjacent. So tangent of 16, 5750 divided by, we'll call that X. Swap. Big number. Okay, and then in this one, so I'll do tangent of 31 is my same altitude or height. I'll call this Y. And so then I'm just going to swap again. So Y is 5750 divided by tangent of 31. 9569.6. And then I need to subtract these to find just A to B. So I'm going to go back up, hit enter, minus, enter. 10,483